On question 14, we have this problem that seems, at first glance, like it's pretty impossible because we have the area of the square is 36. They tell us the area of the triangle is 20. They tell us EB is perpendicular to BF. Okay, that's marked in. And we have AE equals 2. And what I want to do is I want to find this length of C to F. Doesn't seem like one has much to do with the other. But let's start just working our way through things we can find. We'll start with this. The area is 36. Well, if the area of the square is 36, I know each side is 6. And then, because I know A to D is 6, that tells me E to D is 4. Okay, well, that helps me a little bit. Now, we know the area of triangle EBF is 20. That doesn't seem like it helps me too much, but look at here to start with. Let me highlight this. We have a we have a right triangle because it's a square. So I know AEB, I can use Pythagorean theorem to solve BE. So I'm going to say C squared. There we go. C squared equals A squared plus B squared. I'm looking for the hypotenuse, so I'm looking for C. So equals 6 squared plus 2 squared. So C squared is going to be 36 plus 4. C squared is going to be 40. Take the square root of both sides. C is the square root of 40. I'm going to simplify that. So that's, let me see. That's the square root of 4 times the square root of 10, or 2 square roots of 10. So I know E to B is 2 square roots of 10. Now I can use that fact because I got the area of the triangle. So I'm going to say 1/2 base times height equals my area. So I'm going to take 1/2. My base is going to be 2 square roots of 20 times my height. And I know that's 20, right? In other words, h times the square root of 20, not the square root of 20, can't copy, square root of 10, equals 20. So h then is 20 divided by the square root of 10. We'll rationalize that denominator. So I get 20 square roots of 10 all over 10. No square root, just 10. Oh, that'll give me 2 square roots of 10. I better go back and change that to my square root of 10, huh? So in other words, I got an isosceles triangle, don't I? I know it's 2 square roots of 10 for each base. And then I can find E to F, can't I? Using Pythagorean theorem because I got my 2 legs. So I'm going to say C squared equals A squared plus B squared. C squared is E to F equals 2 square roots of 10 squared plus 2 square roots of 10 squared. So E to F is going to be 4 times 10 plus 4 times 10, or E to F will be 40 plus 40. E to F is 80. Take the square root of that. That's the square root of 16 times the square root of 5. So I get 4 square roots of 5 for e to f. Oh, there we go. You see how we're going now? Now let's use Pythagorean theorem and triangle. Let's trace this so we know what we're looking at here. Let's take a look at triangle EDF. So I'm going to use Pythagorean theorem there. So I'm going to say, oh, oops, I always forget to change it back to my pen. Let's go c squared equals a squared plus b squared. In other words, my hypotenuse this time is 4 square roots of 5 squared. Probably didn't need to simplify that because that's going to be 80, isn't it? Equals 4 squared plus x squared. X is going to be my whole length here. And so my whole length is going to be 16 plus x squared. I will minus 16 from both sides. So x squared is going to be 10 minus 6 is 4. 7 minus 1 is 6. Oh, x squared equals 64. So I know this whole length is going to be 8. And if the whole length is 8, that means c to f is 2. So we just had to do Pythagorean theorem 3 times in the area of a triangle once. I don't know if you really need to simplify all those square roots because we ended up using them in other parts. So when you do your work, you don't necessarily have to go back and do that square root. But get that for an answer. That was kind of a cool question. I like that one. Okay, number 15. I want to find the vertices of a square with diagonals y equals x and y equals negative x plus 6. Well, let's do this. Let's graph this. Okay. So we'll do y equals x and y equals negative x plus 6. What's wrong with my first one? Let's have a dot or something there. Let me get rid of that one. There we go. Y equals 6. No, x. Okay. Well, the cool part about this is I can see the diagonals intersect, and they're going to be at a right angle. So if I look at this one of my coordinates looks like it's going to be at 2 and 4, doesn't it? So if I graph 2 and 4, and I'll label that just so we can see it. And then if we graph 4 and 4, whoops, 4. I'll label that one. And then I'd have a point at 2 and 2, wouldn't I? And my last point is going to be at 4 and 2. And I know that because I know all the sides are the same. I know the diagonals intersect. I already see they're opposite reciprocals. It's going to make them the same. Now, if you look at my answer key, I think I use 0, 0, but there's more than one correct answer here. So we're going to say 2, 2. Oops. Get out of there. 2, 2. 2, 4. 4, 4. and 4, 2. Now those you got to score with a side length of 2. And there's your answer for that one. I think that's it for this assignment 2.